Okay, guys, so we started this on Friday, but we didn't get very far, so I redesigned everything, and hopefully I can make this very understandable for you. What we're talking about here is the altitude-on-hypotenuse theorem, and we're going to get to the actual theorem in a second. But I want to show you the mechanics of what happens when you have an altitude, okay, drawn from the vertex of a right triangle. As you can see, CD is the altitude, and it's drawn from the vertex of the right angle, right triangle, ACB. So you guys can understand, again, that CD is an altitude drawn from the right angle from the right triangle ACB. Everyone can see that? Yes, you promise? Okay, now, one thing that one of my students had asked me about, I think it's very valid, and I want to go over it with you guys, is how do you get all three of these to be similar to each other, Mr. Morrow? That was the question. Well, hopefully I'll have an answer for you that makes sense, and this will help everything for the rest. No, not reflexive. Let me go over it, please. Okay, when you have big triangle here, ABC, and then you have little triangle, ACD. So you have the blue and the red here, correct, my brothers? Okay, you have a right angle for the small and a right angle for the large, correct, my brothers? So that's one angle already, correct? But aren't you also sharing a second angle A because of reflexive? So it's because of reflexive that you have the first relationship. But I thought that you were insinuating that the reason that all three are similar is because of reflexive. So I just didn't understand what you were saying. You have to articulate. Thank you, sir. So does that make sense how I go from AB to AC? You with me? Okay. Now, let's investigate now, gentlemen, ACD and CBD. ACD and CBD. Actually, no. I'm sorry. Wrong one. Wrong one. That's the one that we're going to prove because of something else. Sorry about that. Let's go. Yes, it is transitive. ABC to CBD. Sorry about that, brothers. Okay? So in this case, this is your second triangle. Okay. We have a right angle, and we have a right angle, and angle B is being shared. So we know that ABC is similar to ACD, and now we know that ABC is similar to CBD. Yeah. ABC is similar to CBD. So then now, how is ACD similar to CBD? Because of transitive property. So the reason that all of them are similar, two similarities are because of angle, which we just proved. And then the third similarity is because of transitive. If ABC is similar to ACD and ABC is similar to CBD, then ACD is also similar to CBD. That's called the transitive property. Yes, sir. He said on the test and quiz, that's how the proofs are going to be? No, not even close. This is just showing you how and why ABC, ACD, and CBD are similar. I wanted to make that clear for everybody before I started anything. Because the question was, one of my students said, how are ACD and CBD similar, Mr. Morrow? And there's no angle to prove it. So when you work all three of them, you realize that it's transitive. Thank you, son. Yes, sir. Thank you. I appreciate that. Yes, sir. No, it's not an indirect proof that I just did. I just proved that two were similar, and then I got to the third similarity because of transitive. Kind of a detour, more of a detour proof than an indirect. Okay? Now, Okay. So, let's go to now our 3 different scenarios. Okay? Scenario 1. They are stating that ABC, which is going to be here in red, is similar to ACD. Now, this is the part that I think is going to make everything clear. What is the shared side of both of those triangles that I just outlined? AC. Very good. So since AC is the shared side, that is my mean. Remember, we have extremes and means. So that is my mean. So check it out, my brothers. Large side AB, large side AB to large side AB to AC, which is the hypotenuse of the small. Now, that is a shared side. So not only is it the hypotenuse of the small blue triangle, but it's also the large side of the red large triangle to AD, which is the small side. So in the middle here, to make your life easy, it's the shared side. So you could have gone AC to AB equals AD to AC. Same thing. The mean here is the shared side. Always. Now check this one out, gentlemen. I've got ACD, which I'm outlining in blue, and I've got CBD, which I'm outlining in green. What is the shared side? CD. Thank you. Very good. So since that's the shared side, that's my mean. So check it out. AD, which is small triangle, to shared side, equals shared side to larger side, DB. Does that make sense, boys? Okay. And last but not least, ABC, whole big triangle in blue, to CBD, which is this red triangle that I am poorly outlining. I'm sorry. What is the shared side here? CB is correct. Let's just make it a different color. CB is the shared side. So now, AB, which is large, to shared side, equals shared side to small, DB. So instead of worrying about hypotenuse and it's a leg and all this stuff, think of it as shared side. So let's go back to the top. AB, which is large, to shared side AC. Shared side AC to AD from the small. Done. AD, small blue, to shared side CD. Shared side CD to DB, large green. Third one. AB, which is the large side, to shared side CB. Shared side CB to DB, which is the small side of the red triangle. Yes, sir. No, this is not like the way we were doing it before. We're not going from technically corresponding parts because now we have a shared side. So this only happens, this only occurs when you have an altitude coming from a right angle. And that's why, actually, great question, we have a theorem for it. And it's Theorem 68. And it states that if an altitude is drawn to the hypotenuse of a right triangle, then a few things are going to happen, gentlemen. You're going to first know that all 3 triangles are going to be congruent. Okay? Similar, I apologize. Similar completely. My bad. Number 2, you are going to know that x to h is the same as h to y. How come, Mr. Morrow? Because h is the shared side for triangle ADC and BDC. Everything that I'm doing here, I already did in the last slide. This is just the actual theorem that we're working on now. Sorry about this. Apologize. And then you have your third statement. And I should put here and, because it really depends on which side you're talking about. Okay, so I'm going to go ahead and actually make that blue so that you can see it. Okay, so now we know that since I have an altitude coming from a right triangle, all three sides are going to be congruent, similar. I know that since h is the shared side here, x to h will equal h to y. H is the mean. And then, when CD is not the shared side, I have y to a is equal to a to c. In that case, for this guy, red was the shared side. For number 3, blue is the shared side. And for number 3, x to b equals b to c, green is the shared side. Now I want to make sure that you guys understand this, especially by the shared side. That's the easiest way to really understand this. Once you got this, the application of it is really easy. Does that make sense, my brothers? Yes, sir. C is the whole entire AB, my brother. No, that's little c. This guy's little, whoa. This guy's little c, lowercase. That's capital C. That's different. That's an angle. Does that make sense, brother? Okay. May I continue? Yes. Okay. Okay. Let's move on. All right. So for problem 1, gentlemen, I'm going to tell you if AD equals 3 and DB equals 9, I want you to find CD. What I like to do, me personally, I like to mark the shared side. I'm a very visual person. I know that a lot of you already have the answer while I've been talking, and I'm proud of you for that. Some of us, though, me included, cannot see it so easily. So I like to make sure I highlight it, me personally. That's my X. Is that not the shared side for triangle ADC and BDC? So then couldn't I solve this by going 3 to x equals x to 9, small side to shared side to larger side. Does that make sense, my brothers? So x squared is going to equal 27, which equals, doesn't equal anything yet. I'm going to have to square both sides to cancel out the square. So I square root both sides. So I got x equals plus or minus 3 square root of 3. Am I allowed to have a negative side? No, it doesn't work that way. So it's only 3 radical 3, and you're done. Does that make sense, gentlemen? Yes, sir. The question was, do you always want, do I want you to always simplify the radical? Absolutely, please, 100%, sir. If you put the square root of 27, I would mark it half off because it's not complete. Thank you, sir. Yes, sir. Well, in this case, my brother, the shared side is CD, right, my man? So I was using triangle CBA and I was using triangle CDB. And the blue in the middle, that's the shared side, my brother. Okay? Thank you, son. All right. Got to move on, guys. I'm sorry. Problem 2. What if I tell you that AD this time is 3, DB is 9, and I want you to find ACX. Please, for anyone that's having a little bit of trouble, look at what I'm doing. I make this easy for myself. AC is the shared side, correct? What's the shared side to which triangles? ACD and ACB. Very good. Very good. So the blue in between the green and the red, that's the shared side. So I'm going to have small side to shared side equals shared side to 12, which is the whole entire side of the large green triangle. So then, very good. I heard someone say the answer. X squared equals 36, square root to both sides. X technically equals plus or minus 6, but X only equals, for our purposes, positive 6, because you cannot have a negative side. Yes, sir. The given numbers are going to be the extremes? Not always. And I'm going to show you now an example right now. Thank you. The question was, oh, I just put the given numbers as the extremes, right? Not always. Let me show you an example of that immediately right now. What if I were to tell you, gentlemen, that DB equals 21, AC equals 10, and I want you to find AD this time. Now, think. What is the shared side here? 10 is the shared side. To which two triangles? To ACD and to ACB. I heard someone go, oh, that means that it's getting through to you. I'm proud of you. Good. Okay. Thank you. Great job. I was just told what to do, and they told me X, which is small side of the green triangle, small triangle, to shared side, equals shared side to large side of the large triangle, in other words, the other hypotenuse, which is X plus 21. So now you cross multiply, my brothers. This is not difficult. X squared plus 21x equals 100. Great job, son. You set it equal to 0 by moving the 100 over, so I got x squared plus 21x minus 100 equals 0. Now I factor. You don't need to use the cubic method here because you don't have a coefficient in front of the x squared. All you do here is x, what times what equals negative 100, but when added together is positive 21, positive 25, negative 4. So x equals negative 25 and 4. You can't have the negative, so x equals 4. Let's pause for 1 second. All right. Now for this last example, guys, we got a proof. Bless you. They tell you that PK is perpendicular to JM, RK is perpendicular to JP, and that KO is perpendicular to PM. All right? They want you to prove that PO times PM is equal to PR times PJ. If you think about it, it makes sense. They're looking at small to large being equal to small to large. So that's what they're looking for. It makes sense. Let's see what the heck to do. As always, we first give our first proof, okay, which is the given. So we're just going to put in here given. Okay? But now that we know that PK is perpendicular to JM, what can we prove from there? PK is an altitude, but we don't want to mention that yet. You could have said that and it wouldn't have been wrong. But what we do know for sure is that PKJ and PKM are right angles. Not is a right angle, but are right angles. So PKJ and PKM are both right angles. Okay, this is straight up definition of perpendicular lines. Now, almost. Now you use the next given. RK is perpendicular to JP. So that's a given. Okay? Now, in the book, they skipped this next part. I don't know if I would have skipped it, but I can see why they did. I was always thinking, okay, first define that KRP and KRJ are right angles because definition of perpendicular lines, but they don't need that. Thank you very much, son. Is this RK? I'm going to label it here in red. Isn't this an altitude to the right triangle PKJ? So can't we now define that as an altitude? You with me? Now, why is it an altitude? Segments, okay, formed from right triangles are altitudes. It's stated in Theorem 68, right? You got a segment coming from a right angle, that segment is an altitude. That's just the way it is. That's just the law. Okay? Now, from there, I didn't give you any more hints. What do you think we do from here? We know, okay, that RK is the altitude and we have PJ as the hypotenuse. So my question to you here, guys, is what is the shared side? Think about this. Look at this whole triangle here. Thank you, whoever said PK. Doesn't PK, isn't that shared for JKP and for PRK? So can't I say that PK to PR equals PO to PK, giving me that PK squared equals PO times PR. Do you guys see that? I'm sorry, it's not PO. Where the hell am I going with this? Sorry. You could do it either way, but yes, that's fine, son. So go PR to PK shared side equals PK shared side to PJ the whole. So that equals PK squared equals PR times PJ. Don't you have half of the proof right there? Correct? Now this one we can call this hypotenuse altitude theorem. Now, I see that you guys are all getting anxious. So let me just, real quick. From here, now I would say that KO is perpendicular to PM. Given. Now if KO rather, is perpendicular to PM, isn't KO now the altitude? And if KO is now the altitude, isn't PK the shared side again? So then, I'm skipping a step here, but then wouldn't it be that PK, that PO to PK equals PK to the whole entire thing? No, PM. So that PK squared equals PO times PM. You with me? So look at what we have here, though. Doesn't PK squared equal PR times PJ? And doesn't PK squared equal PO times PM? So can't I prove this bad boy by saying PR times PJ equals PO to PM because of transitive property? So remember, guys, the best way to solve these is by labeling and identifying your shared side. May God bless you. Have a great day. Thank you.